Welcome to Algebra Prep Academy. Today's lesson is going to be on Trapezoidal Rule. Before we begin using Trapezoidal Rule, we first must know the area of a trapezoid, which is height over 2 times base 1 plus base 2. Here's an example of finding the area of a trapezoid. The height of the trapezoid is 7 feet, and the bases are 16 feet and 18 feet. Plugging these into the formula will give you a total area of 119 feet squared. This is important to note because we will be finding the area under the curve of a graph by forming trapezoids and finding the sum of their areas. The area under a curve can be calculated using the trapezoidal rule. That can be found by doing b minus a over n, where n is the number of parts. We will explain the formula in more detail in the following example.
In this example, we will be finding the area under the curve from the given chart. Because there are 5 values, n equals 4, and there are 4 partitions or 4 trapezoids. Since the last x value is 5, b equals 5, and since the first x value is 1, a equals 1. To find the height, we must use b minus a over n, which would be 5 minus 1 over 4, which equals 4 over 4, or 1. Now we must divide the height by 2, which comes out to 1/2. Since the difference between the x values are equal, each of the heights will be the same. Now that we found h over 2, we can now begin plugging in our values into the equation. So we replace b minus a over 2n with 1/2 and substitute the f of x values. Now that we have substituted the f of x values, we must multiply all of our f of x values by 2, except f of 1 and f of 5, because these are the starting and ending values. After this, we would plug in the actual values of f of x, so f of 1 equals 5, f of 2 equals 3, f of 3 equals 7, f of 4 equals 5, and f of 5 equals 2. After that, we would do simple algebra and add them all up and find the sum. Finally, multiply the sum by h over 2, which we found earlier as 1/2. Doing these steps, we find our final answer as 37 over 2 for the approximate area under the curve. For our next example, we are going to be approximating the area under the curve with 6 partitions for f of x. F of x is the integral from 1 to 6 of the square root of x plus 3 dx, with the domain being x is greater than or equal to -3. H is given by b minus a over n, and since b equals 6, a equals 1, and n equals 6, h is 5/6. We must then divide the height by 2, which equals 5/12. We must then use our values within the formula used for trapezoidal rule. Plug in the f of x values at each point into the equation, then multiply their sums by h over 2, or 5/12. As you go through the problem, make sure you correctly substitute the f of x values, as one small mistake can yield the incorrect approximation at the end of the problem. Also, as you go through the problem, if you will notice, the point at the beginning, f of 6/6, and the point at the end, f of 36/6, will appear only once, while all the other points in between will appear twice. After this, calculate the f of x values by using the original equation, the square root of x plus 3. This would give us the results that are shown. Finally, through basic arithmetic, you should get about 30.388 for the sums. Then multiply this by 5/12 to get your final answer of 12.66185,088 for the approximate area under the curve.
So for the final example, we will use trapezoidal approximation and unequal partitions to find the area under the curve. Unlike the other two problems, the heights of the trapezoids are not equal, so we must find each one's individual area. In order to find the height of each trapezoid, you must subtract the first one of the trapezoid from the second, so the first height would be 1 minus 0, which is 1. Then the second would be 3 minus 1, which is 2, followed by 6 minus 3, which is 3, and finally 10 minus 6, which is 4. Now you must find the area of each trapezoid by multiplying the sum of the bases of one trapezoid by its height. All you have to do now is substitute in the values for f of x. Then add these areas and divide by 2 to find the approximated area under the curve, which gives us the answer 350. Thanks for watching!